Hello friends, today we'll see one of the important topic of memory management unit, that is segmentation. We have seen paging and now we are gonna study segmentation. I am Mahesh Sangvi, working as Professor and Head, Department of Computer Engineering, SNJB's Letso KB Jain College of Engineering, Chandpad. I hope you will like this video and surely subscribe this channel. Segmentation means it is one of the memory management schemes that supports as far as user views is concerned about memory. A program is collection of segments. We all are aware that the programs are collection of segments. There are various different segments and compiler generates these segments, and normally loader is assigning the segment number to that particular segment. If you observe here in this diagram, you will understand that there are different segments available into this particular code. For example, main program is a segment, procedure can be a segment, then function can be the segment. So likewise, there are different segments which are available, and we can use this particular segment, and that's the reason segment is collection of logical unit. Here it will specify you about what the segmentation, how this particular segment can be used. So segment has segment name, normally called as segment number, and its offset, that is ultimately what the address means. The way we have seen in case of page, that is page number as well as what its offset, same concept is here where the segment number and the offset is required, and that this particular part is normally known as what logical address. So this is important in case of what users view of program regarding segment. Now if you observe here again, these are the different segments which are given here. For example, subroutine is one of the segments, stack is one of the segment, sqrt is one of the segment, main program can also be a segment, symbol table is also a segment. So every segment will be having what variable size, so size will not be fixed. In case of paging, the size of each and every segment was what fixed, and that's the reason something which is known as fixed size is paging, and if it is variable size we can normally call it as what segment. So what is essential for this? We need its base address as well as what its length, from where it will start and at which end it will go. So it is important. In case of paging, we were only needed starting address. Reason, length was fixed in case of what paging, but in case of segment, length is not fixed because every segment can be have different length, and that is the reason we need this particular part in case of what offset also. Now you can see here the logical address, where the logical address can be what, it can be a segment number and what offset, and this logical address space where you can see that we have different segment like segment 1, 2, 3 and 4 having different length, and these are physically, like long-term scheduler. Actually what it does, it finds and allocates memory. How the memory will be allocated, you can see that it is allocated to 1, then 4 and then 2 and then 3, and everywhere you can see that the length is what varying. Okay, so this way logical address is converted into what physical address by using what segment table. You can see the example of Windows XP where you can see the segments as well as what the first address and last address and its size. So here you will understand that there are what different segments that we can see. Okay, so code is one of the segments, static, global data, heap, stack, all this will, this will store some information. Its starting address is this, that is base address, and the last address is this, so that indicates that it is ending address. And this size means what, this will gives you length. So every segment will have its starting address and its size. When you simply sum up first address with size, you will get what, the last address. That's the beauty. Same is given for Linux memory also. Similar things you can observe here. Here also there is first address, last address as well as what, the size. Now just take an example. Suppose you have written a code on C language and you have compiled that particular code in a Linux environment. What will happen, in that case, the a.out is one of the program executable code which will be available to you, and you need to focus that there will be two symbols, one is sqr, another one is sum. Okay, and the start address of sum is what, 0, and the address of sorry, sqr is 0 and address of sum is what, 4. This we can do by using what we have seen this in case of assembler also. So paging view will be like that: at 0th location there will be load, and at 4th location there will be what, add. Okay, and here you can see that the segmentation point of view, how it will be look like. Segmentation point of view, you will get what, this particular addresses like this, where the addresses will be load st comma 0 and then st comma 1. So this symbol table addresses which will come. So this way you can understand that the difference between what, the paging view and the segmentation view. Now segmentation architecture, that will give you again what, an idea that this particular part will tell you that logical address he is here having two tuples. Which two tuples? Segment number as well as what, offset. Now here you can understand the entire detailing of what this entire detailing of what, each table, what exactly that particular table will contain. So segment table, it maps two-dimensional logical address to physical address. You should be aware that the way paging table was used for mapping your logical address to physical address, same segment table is also needed for what, mapping your logical address to what, physical address. So this is clear. Okay, but what it has, this particular table will have some entries like, you will be having base register, means the starting address of that segment. Limit means what, the length of that particular segment. Then one of the register which will point to what, base, and another register that will actually point to what, the length of that particular register. Now why this is needed? Because this will act as what, protection unit. Okay, and also we need what, one more part that we need to understand here. The meaning of base is what, the meaning of base is quite clear. Okay, what is base here? So base is ultimately the starting address, and limit will be what, the length of that particular segment. We need both the cases. So for pointing to base we need base register, and for pointing to limit we need what, limit register with this base and limit. So there will be 4 entries into that table. So these are the segment table base register which will point to the base, and this is what the segment table length register which will point to what, the length. And this particular thing you should understand by using what, the protection bit. Now this protection can be done by using what, the protection bit. If the protection bit, that is ultimately valid bit, is 0, it is illegal segment. Okay, means the task of segment is over and it should get out of what, it should free that particular memory. Otherwise it will give you options of read, write or execute. So when code sharing occurs at what, segment level, we need to focus on this two particular part, where the length of the segment can be vary. So memory location can be what, dynamic allocation. So we need what, long-term scheduler, and we can use any of the dynamic scheme like first fit or the best fit, so that the issue of fragmentation will not arise in case of this. So here you can see the example, and this example will clarify you that suppose there are different segments like segment 0, then segment 1, then segment 2, segment 3, segment 4. Okay, and this will be what, the segment register. This segment register has two entries. One is the segment number, and in case of offset what we need is limit as well as what, base. So this base will tell you that the 0th segment will start from what, this 14. Okay, you can understand from this that this limit, like that, this 0th segment will start from this 1400, right? And it ends at what, its limit is 1000. So from 14 to, it goes to what, your 2400. It means that it takes that particular thing. So this way you will understand that every segment is what, well managed. Every segment is well managed here by using this particular diagram, and this diagram will give you an idea. So ultimately what is happening here, segment table is used to convert logical address space into what, the physical address space. Same in case of your paging. Now this is what the hardware of what, segmentation. Many times the question comes into what, the question comes into what, in examination, that you have to follow this, where CPU is actually what, it is generating logical address in the form of SND. This S will be what? The segment thing. So it will be searched at what? The segment table. It will give you two things. One is limit and another one will be what? Base. If the limit is less than what your offset, then we can say that yes, no problem, you can add that particular value into base register and you will get what? The physical address. So your logical address is converted into what? The physical address just by adding base address. What we need to check by using limit, whether that offset is going beyond the limit. If that is the case, then there will be naturally there will be what? Error, because it is actually what? It is actually hijacking to what? The next segment, which is not good. So that's the logic. So the segmentation with paging, if you observe, because it has, we have seen that the paging has its own limitations of internal fragmentation. Segmentation will also have a problem of what? The external fragmentation. If we combine these two techniques, we can take care of the problem of paging as well as what? The segmentation. So we can able to sort out both the problem of what? Fragmentation. So what is an idea? We can take a segment, then it will be splitted into what? The multiple pages. Okay, we will take what? The segment. Okay, it will be splitted into what? Multiple pages. So each page is loaded in a frame, and that will be ultimately what? Memory. So what is an idea? Segment will be splitted into multiple pages, so that we need to take and key idea in this particular case. Just take an example. This example may clear you what the sum of the things. Each segment can be a 4 GB. The size of segment is what? 4 GB, and up to 16K segments per what? Process. So it will move from 4 GB to what? It will take what? The segment per process like a 16K. So the selector will be what? 16, and the offset will be what? The offset will be your here the 32. And here you can understand that there will be what? The segment, there will be what? The value, then there will be what? The paging. So this way the scheme will move or support what? Segmentation as well as what? Paging. Now you can understand here from this diagram that segment is divided into first partition and the second partition. In first partition, up to 8K segments are private to process. It will be private to process, and here the segments will be shared with all the processes. Okay, so this is normally known as what? LDT, that is local descriptor table, and here it is known as global descriptor table. The name local and global is very simple. Local is mainly used for private processes, and when you are sharing the processes, in that case you need what? Global descriptor table. You can see here, this is what an example of what? IBM. Okay, and here you can understand that CPU generates what? The local addresses. Okay, normally in six segment register, given to what? Segmentation unit, which produces linear address. Okay, so physical address will be what? 32 bits, and linear address given to paging unit, which generates physical addresses in main memory, and that will normally known as what? MMU, that is memory management unit, and the size of page will be what? 4 KB. Now if you observe this, the logical to physical address translation that can be done in case of what? Your Pentium will be like this. CPU will generate what? The logical address, then it will be given to segmentation unit. So segmentation will come first, it will generate linear address, that linear address will be given to paging, and paging will finally convert it into what? The physical address. So this is what an idea behind what? The segmentation and the paging unit, where the logical address is given to segmentation unit, which will convert it into what? The linear address, then that linear address is given to paging, and it will convert it into what? The physical address, and this way we can able to use that particular part. This will again show you the same part that I have or just told you about this, where first there will be what? The segment, then the segment descriptor will work out, that will be added into what? The offset, then the page address will be generated, and from this we can understand that this directory entry will give us some information, and paging will give us what? The physical address, that is what? The frame number, and this way we can able to execute. So only the discussion that we made into last thing is made here. So you can understand here we need what? The segment register. So here again it will clear you about what it does. Selector will take this address, then it will be searched into what? This table, then it will be added, and finally linear address will be generated. So you need to understand from this that segmentation will help us to take logical address, and it will convert it into what? The linear address, and finally that linear address will be taken into whom, it will be taken into the paging. And what paging will do, paging will search into what the page directory, then it will take what the page number, then finally it will take what the frame number, and finally this entire part is converted into what the physical address. That's the beauty. I hope you must have understood the use of segmentation as well as segmentation and paging. In next session, we'll see about virtual memory. Thank you.